So in this tutorial, we're going to round up some of the best 3D printers of 2026. Now, there's no strict ranking here. Instead, what I've done is I've grouped these printers by brand, and I've just aimed to cover a very wide range of budgets, materials, and use cases. Also, be sure to stick around until the end because I'm going to teach you how to get better plastic print quality, even if you opt for one of the cheaper printers on this list. So let's jump in. Now, the most logical place to start is with Bambu Lab. Now, they've established themselves as a leader in the consumer and prosumer 3D printing space with a lineup that spans different price points, materials, and experience levels. So you'll see multiple Bambu Lab printers on this list. So we'll start with the smallest and the most affordable. Now, first up is the A1 Mini, which is essentially a scaled down version of the A1 that I'm going to talk about in a moment. Now, the base price typically sits around $219 for this printer, with the option to add the AMS light for automatic multicolor filament switching. Now, if you're not familiar with it, the AMS light allows the printer to automatically swap between multiple filaments for multicolor prints. That said, the A1 Mini works perfectly well as a single material printer or for simple manual filament changes. With the AMS light added, the total price usually comes in at just under $400. Now, one of the biggest differences between the A1 Mini and the full-size A1 is the build volume. The A1 Mini has a 180 by 180 by 180 millimeter build area, which makes it better suited for smaller parts, things like miniatures, toys, and general household objects. For larger designs, many users simply split models into multiple parts using joints, alignments, pins, tabs, or dovetail style connectors in their CAD software, and then assemble them after printing. And that makes the smaller build plate much less limiting than it might sound. The reason the A1 Mini is so popular is that the print quality is essentially identical to the A1. Print speeds are also mostly the same, so you're not sacrificing performance, really just build size. From a material standpoint, the A1 Mini handles PLA, PETG, and TPU very well. Like most printers in this price range, it's not going to be ideal for higher temperature or engineering grade materials, but of course that's completely expected given the design and cost. Now, one quick tip that really helps people get most out of their 3D printers, like the A1 Mini, is obviously to start with a strong design before you ever even open your slicer. So for example, in Light here, what I'm going to do is I'm just going to take a rough concept or even just a napkin sketch. I can then turn that into a polished product design, and then I can convert that into a usable 3D mesh using this image to 3D tool here. Then once I have this mesh ready, I could then just import it directly into Bambu Studio, scale it to fit the A1 Mini's build volume, slice it, and then print it. Now, this kind of workflow is especially powerful on smaller budget-friendly printers because when the design is clean and intentional, even inexpensive plastics printed on compact machines can look surprisingly professional. So if you're interested in being able to design unique and more professional 3D prints for your 3D printer, a link to Lightloop's AI 3D generation tool can be found below. Okay, next up we have Bambu Lab A1. Now, this is the full-size version of the A1 Mini, and it's easily one of the most popular 3D printers on the market right now. The A1 typically comes in at around $359, which is roughly double the price of the Mini. Now, if you want multicolor printing, you can also add the AMS light, which usually adds another roughly $170 to $250, depending on the current pricing and bundles. Now, the biggest difference between the A1 and the A1 Mini is the build volume. Now, the A1 has a 256 by 256 by 256 build area, which opens the door to noticeably larger projects. This size is going to be great for things like medium-sized mechanical components, larger decorative or display pieces, or prototypes that would need to be split on the A1 Mini. In a moment, I'll talk about the Bambu Lab P1 series, but one thing you'll often hear from users who choose the A1 over the P1 is that the A1 is generally quieter. Now, that's partly due to its motion system and overall design. The trade-off here is that the A1 is slightly slower than the P1 models, though for most real-world prints, the difference isn't going to be very dramatic. Now, just like the A1 Mini, the A1 performs extremely well with PLA, PETG, and TPU. However, it's not designed for higher temperature or engineering-grade materials such as ABS, ASA, nylon, or carbon fiber reinforced filaments. That's mainly due to the open frame design and lack of heated enclosure, which is typical and completely reasonable at this price point. Okay, next up we have the P2S, and this is where Bambu Lab's lineup starts to move firmly into the prosumer territory. So as you can see here, the P2S is fully enclosed, and that single design choice dramatically expands what this printer can do, as well as who it's for. Now the P2S typically comes in at around $550 to $600 for the standalone version, or $900 for the combo with the AMS2 Pro, making it a more premium option compared to the A1 series, but significantly more capable in terms of materials, performance, and user experience. Now the P2S has a 256 cubed build volume, the same as the A1 and the P1S. So in terms of sheer size, you're not really gaining or losing anything here. It's still an excellent format for functional prototypes, mechanical and structural parts, or production runs of smaller parts. Now where the P2S really separates itself isn't size, it's the second generation technologies, things like enhanced materials capabilities and refined user experience. So thanks to the fully enclosed design and 50 degrees Celsius chamber capability, the P2S can reliably print a much wider range of materials than the A1 series. So in addition to PLA, PETG, and TPU, the P2S handles ABS, ASA, nylon, profiles like PA, PA6, EF, and so on, PC, as well as extensive carbon fiber and glass fiber reinforced filaments. Now the P2S features an adaptive airflow system that draws cool air for low temperature filaments or seals heat for engineering grade materials. So for anyone building functional parts that need heat resistance, strength, or outdoor durability, this is going to be a huge step up. Now the P2S is compatible with Bambu Lab's AMS2 Pro system, supporting up to 20 colors by connecting multiple AMS units. Now this makes it ideal for multicolor consumer products, branded components, and complex visual prototypes. The P2S also features significant hardware improvements. So for example, here we have a 5-inch touchscreen display. We have a 1080p HD camera, AI air detection, quick swap nozzle system, as low as 30-second changes, and active flow calibration for precise extrusion. Now this 3D printer is essentially an evolved version of Bambu Lab's iconic P1S printer, which really kind of represents the point where users transition from maker into more serious prototyping or manufacturing workflows. Now, next up, we have Bambu Lab H2C, and this is where Bambu Lab really takes a completely different approach to multi-material printing. So the H2C uses Bambu Lab's revolutionary Vortex hothead change system. So instead of purging filaments when switching colors, the printer physically swaps between up to 7 different nozzles, each dedicated to a specific filament. So this is going to dramatically reduce waste and print time compared to traditional multi-material systems. So the H2C typically comes in at around $2,400 to $2,500 for a basic setup, making it a significant investment. But for anyone doing serious multicolor or multi-material work, the waste savings alone can really justify the cost. The H2C has a build volume of 330 by 320 by 325, so it's larger than the P2S, but where it truly stands apart is in eliminating purge waste. The H2C reduces this waste by up to 80% by simply switching nozzles instead. So the H2C handles the full range of Bambu Lab filaments across all 7 nozzles, including PLA, PETG, ABS, ASA, TPU, PC, nylon, PPS, and fiber reinforced variants as well. Now, with a 65 degrees Celsius actively heated chamber and 350 degrees Celsius nozzles, this printer is ready for very serious engineering materials. So the H2C is ideal if you print complex multicolor models and want to eliminate waste. You need to combine multiple materials into single prints. You run a business where filament waste impacts your bottom line, or you just want the most advanced multi-material system available. At the end of the day, the H2C is a production powerhouse designed for professionals who need uncompromising multi-material capability. Next, let's talk about Prusa, and specifically the Prusa Core 1L. So Prusa printers have a very different reputation compared to Bambu Lab. So where Bambu emphasizes speed, automation, and polished consumer experience, Prusa has built its name on engineering reliability, print accuracy, and long-term durability. Now, the Core 1L represents the most advanced expression of that philosophy. Now, in terms of pricing, this printer can generally be found for around $1,800, positioning it as a serious investment for professionals and dedicated makers. Now, the Prusa Core 1 features a large format build volume of 300 by 300 by 330, double the volume of the standard Core 1, and significantly bigger than the P2S. That makes this 3D printer ideal for large functional parts, one-piece prototypes that would otherwise need splitting, or for the low-volume production of larger components. Now, one of the standout features of the Core 1L is its new AC convection heat bed with active air circulation. This massive aluminum block essentially provides perfect uniform heat distribution from edge to edge, so you're not going to have any cold spots. You don't have to worry about warping because this block essentially heats the 60 degrees Celsius chamber remarkably fast and evenly. Now, the Core 1L is built to handle engineering grade materials reliably. It works well with PLA, PETG, ABS, ASA, nylon, PC, and fiber reinforced materials with the included abrasive resistant nozzle. Now, this makes it particularly well suited for production grade parts, things that need strength, dimensional accuracy, and thermal stability rather than just visual appeal. Now, while the Core 1L offers impressive speed with its Core XY kinematics and high flow nozzle, it focuses heavily on consistent layer quality, precise extrusions, and predictable, repeatable results. For businesses and engineers, that consistency often matters more than shaving a few minutes off the print. Also, for context, Prusa has a bunch of great 3D printers. So they have the Prusa Mini Plus, which is a compact, reliable entry-level machine. They have the Prusa MK4S, which is a refined all-round workhorse. They have the Prusa XL, which is designed for large parts, multi-material workflows, and obviously production use. And then a more recent offering, which is the Prusa Core 1L, which again is designed for large parts, advanced materials, as well as for production use. Now, next up, we have the QIDI Max 4, and this is a printer that's very clearly designed for large format production grade work with engineering materials. Now, QIDI has built a strong reputation around fully enclosed high temperature printers, and the Max 4 represents their most ambitious platform yet. It's aimed squarely at users who need serious build volume, chamber heating, and the ability to handle demanding materials without compromise. So pricing for the QIDI Max 4 typically falls around $1,100 to $1,400 for what you're getting, particularly the build volume and active chamber heating. That's an extremely competitive price. So the Max 4 offers a massive build volume. It's 390 by 390 by 340, making it one of the largest enclosed printers in this price range. Now, the size is going to be ideal, of course, for things like large functional parts and industrial enclosures. Now, where the Max 4 really stands apart, though, is in its third generation active chamber heating system, which reaches 65 degrees Celsius. The Max 4 is built to handle the full range of engineering materials, so for example, PLA, PETG, ABS, ASA, nylon, or PA, PC, and carbon glass fiber reinforced filaments as well. So with nozzle temperatures up to 370 degrees Celsius and an ultra uniform 390 by 390 heated bed, this printer is going to deliver consistent results even with the most demanding materials. The Max 4 is also compatible with the QIDI Box multi-material system, so it can support up to 16 different colors or materials. So if Bambu printers lean towards speed and polish, and Prusa leans towards engineering precision and consistency, the QIDI Max 4 leans hard into large format, materials first manufacturing at an accessible price point. Next up is the Formlabs Form 4L, one of the most production-focused resin 3D printers available today. Unlike most filament-based machines, this is a large format SLA printer built for high precision, smooth surface finish, and consistent part quality across large batches, making it a favorite in industries from engineering and automotive to tooling and customer products. The Formlabs Form 4L starts at around $10,000 for the base printer, and a complete production setup with wash and cure stations can push the total investment closer to roughly $18,000 to $20,000. Now, the Form 4L has a large build volume of 353 by 196 by 350, giving you the ability to print big parts in one piece or high quantities of smaller pieces in the same batch. Now that scale combined with SLA accuracy makes it ideal for functional prototypes with very fine details or end-use parts requiring extremely smooth surfaces. Now the Form 4L uses Formlabs low force display or LFD print engine, which significantly reduces peel forces during printing. Now this results in less stress on parts, higher dimensional accuracy, and noticeable improvements in surface quality compared to many bottom-up resin systems. The XY resolution is about 46 microns on this printer, and prints can layer as fine as 25 microns for high detail applications. Now, one of the most impressive things about the 4L is how quickly it can produce large parts. It can handle large objects in under 6 hours and sustain high throughput for smaller parts, which is critical for production settings rather than just simple prototyping. So in short, this is more of an industrial grade resin platform and not so much a hobbyist machine. Now, before we wrap up, 3 quick honorable mentions for anyone looking for solid budget-friendly FDM printers. So first off, we have the Ender 3, which typically costs around $199 and remains one of the best entry-level options for reliable, no-frills FDM printing. Next up, the Centauri Carbon is also worth mentioning. So like the Ender 3, it's known for delivering strong print quality at an affordable price, roughly around $300, making it a great choice for anyone who wants dependable FDM printing without a big upfront investment. And finally, we have the Snapmaker U1, which found massive success on Kickstarter. It deserves recognition as something sort of different entirely. It starts at around $850, and it's a multi-material powerhouse with 4 independent tool heads that swap in just 5 seconds and cut filament waste by up to 80% compared to traditional filament changing systems. So if you're ready to explore multicolor or multi-material printing without the typical waste and wait times, the U1 offers professional capabilities at a surprisingly accessible price point. So there you have it, 10 of the best 3D printers to look at in 2026. Also, just to be clear, this isn't a comprehensive list, of course. There are plenty of good and even great 3D printers that didn't make it into this video. So if your favorite 3D printer did not show up here, simply drop it in the comments below and let us know why you love it. And again, I want to mention that before we wrap up, I just want to share a quick side tip, because even the best printers on this list can still produce parts that look cheap if you're not careful. Now, a lot of that comes down to design and surface treatment, not the printer itself. So doing things like using matte filaments or adding intentional textures and avoiding large, perfectly flat surfaces can instantly make prints feel more professional. Now, print settings also matter too. Lower layer heights help reduce visible layer lines, and features like Bambu's fuzzy skin can help hide print artifacts surprisingly well. And if you're going for a finished look, well, sanding, priming, and painting FDM parts still can go a long way. But honestly, one of the biggest upgrades happens before you ever hit print. If you start with a strong design, you have good proportions, clean geometry, and intentional surface detail, then even cheaper consumer plastics printed on budget machines can look really high-end. Now, this is exactly the problem that we're working to solve at Lightloop. So Lightloop helps creatives elevate their designs by taking rough napkin sketches, turning them into polished product images, and then converting those into usable 3D meshes using advanced AI models. Lightloop is designed to bridge essentially the gap between an idea, a refined design, and something that you can actually print and be proud of. I'll link to Lightloop below if you wanted to go and check it out. But regardless of the tools that you use, the takeaway is this: good design and pre-planning does more to elevate your print than expensive hardware ever will. So thanks for stopping by today, and don't forget to like and subscribe if you found this useful and want to stay up to date on the latest in the product design and 3D printing spaces.